Hi everyone, this is Mrs. G, and today we're going to do a review of how to factor quadratics. So there are a few different methods that we use for factoring quadratics, and this is a skill that's going to be really important when we're solving quadratic equations, and we'll be using factoring pretty much all year, so these are really important skills to master. So these methods will depend on what your equation looks like. So there's four main methods. The first one is to always look for a greatest common factor or a GCF. Now this method you should check for every single problem. It should really be the first thing you look for. So say, is there a GCF that I can factor out? Yes or no. So this one we check for every single time. Now the next three, it depends on how your equation works. So we should know how to use difference of two squares, or some people call it difference of two perfect squares. I call it dots for difference of two squares. And then we should be able to factor trinomials both where that a value is equal to 1 or when a is some number greater than 1. So there are two different methods that we can use for that. But the one thing I want you guys to keep in mind through all of this is that some quadratics are simply not factorable. So if it doesn't seem like it's working, it might just be that it's not factorable. All right, so let's start by reviewing how to look for a greatest common factor or a GCF. So when you're looking for a GCF, you look at every single term in your expression and you see if there's something, a number that you can divide each term by. And in fact, you're looking for the largest number that you can divide each term by. So if I have 3x squared, 9x, and negative 3, our GCF is 3. So once you know what your GCF is, you're actually going to divide it out of each term like this. And then that's the process of factoring it out. When we factor it out, we're actually going to put it in front of our expression. So that's a really important thing. The GCF should not disappear. It goes in front of our expression. And now we just divide. So 3x squared divided by 3 is simply x squared. 9x divided by 3 is 3x. And negative 3 divided by 3 is negative 1. And now this is factored. So we factored using GCF. So 3 is a factor, and x squared plus 3x minus 1 is a factor. Okay, let's look at this next one. Here we have negative x squared plus 7x. So one thing, well, the only thing that they both have in common is actually x. So x can absolutely be part of your GCF. And then here's a little tip. If your x squared term is ever negative, like it is in this problem, it's a really good idea to factor it out. So our GCF in this case will be factoring out negative x. So again, both terms are divisible by x, and we're going to factor out the negative, so this term becomes positive. So remember, put your GCF first. It goes in front of your expression. Here the negatives cancel out, and x squared divided by x is just x. And then here, this will turn this last term negative. 7x divided by x is just 7. So now our expression is factored. Now let's have a look at example C. So sometimes our GCF is a combination of both a number and a variable, so it could have a coefficient with a variable. So let's see if we can figure out the largest thing we can divide into both terms. So I see that both terms are divisible by x, so that will be part of our GCF. Then I have to think, what's the largest number that I can divide into both 12 and 18? And that would be 6. So remember, we're looking for the greatest common factor. Of course, we can divide both of these by 3 or even 2, but then it wouldn't be the greatest common factor and it wouldn't be completely factored. So start by writing your GCF of 6x out front, and then we just divide. 12 divided by 6 is 2, x squared divided by x is x, and then 18x divided by 6x is simply 3. And now we have our factored expression. So that's our quick overview of how to factor using a GCF. All right, so now let's move on to difference of two squares. So we can use this difference of two squares formula only for very, very specific cases. First, as the name implies, It must be a difference, meaning it must have subtraction, and what you're subtracting must be two perfect squares, so a squared and b squared. So everything about the first term must be a perfect square, and everything about the second term must be a perfect square. So if you meet those criteria, so then you can use this formula. So a squared minus b squared is going to be a plus b times a minus b. So notice if this is a squared, we can find a by taking the square root. If this is b squared, we can find b by taking the square root. So this is our difference of two squares formula. So let's have a look at example A. Here we have x squared minus 64. So here I see that there's two terms that are being subtracted. X squared is a perfect square and 64 is a perfect square. So it meets the criteria, so we can use that formula. So if a squared is x squared, that means a is x. And if this is b squared, that means that b is 8 because that's the square root of 64. And then all you have to do is say x plus 8 times x minus 8. And it's as easy as that, as long as you know to look for difference of two squares. Okay, let's look at this next one. I do want to point out for this, the x term does not need to come first to use difference of two squares. So don't try to change it around. We can leave it like this. So here we have two terms. It's a difference. 1 is a perfect square, and then 9 is a perfect square, and so is x squared. So this works for the formula. So here's my a squared term. The square root of 1 is 1, so my a value is 1. Here's my b squared term. Square root of 9 is 3, so my b term is actually 3x. And now I just plug it into the formula. A plus b times a minus b. We can leave it just like this. This is fully factored. All right, let's look at this next one. Here we have 25x squared and 4. So there's two terms, and I see, oh, 25 is a perfect square, so is x squared, so is 4. So this looks really close to difference of two squares, but be careful because this is a sum, not a difference. So don't be fooled when you see something like this. This expression is actually not factorable. So just as a quick recap, anytime you have an expression with two terms in subtraction, it's really good to check to see if you can use difference of two squares to factor. Okay, so now we're going to move on to factoring trinomials, which is an expression with three terms like these. And we're going to start with trinomials that have an a value that's equal to 1. So a is that expression of, or the coefficient of x squared. So if you look at all three of these, it's just 1x squared, 1x squared, and 1x squared. So to factor trinomials like this, I use a method that I like to call magic x. So here's how it works. We're going to make a little x. This term at the back, your c term, the one without a variable, c is always going to go on top. So I'm going to put c right here, 32. And your b value, which should always be the coefficient of x, is going to go on the bottom. And then this is kind of like a little puzzle. We're going to be looking for two numbers that multiply, so I'm going to put a little dot for multiplication, that multiply to make 32 and add to make 12. So it's always going to multiply to make c and add to make b. So then you can kind of go through the different factors of 32. We could do, well, 16 and 2, but that doesn't add up to 12. So you could say, oh, 8 and 4. And so we can double check. 8 times 4 is 32. 8 plus 4 is 12. So those are our magic numbers, and we can use those as part of our factor. So one factor becomes x plus 8, and our other factor is x plus 4. So just be careful here. This is just a method to help us make our factor. The entire factor is x plus 8 and x plus 4. So 8 is not a factor. X plus 8 is our factor. So now our trinomial is fully factored. Okay, let's try another one. So again, I see it's a trinomial. My a value is 1, so I'm going to set up my magic x. So here, be careful. Our c value is actually negative, so negative 20. And our b value is negative 1, so both are negative. So remember, we're looking for two numbers that multiply to make negative 20 and add to make negative 1. So if two numbers are multiplying to make a negative, we know that only one of them should be positive. So you can start trying different things. So maybe we start by trying, well, 5 and 4 we know makes 20, but one of them needs to be negative to make negative 20 when we multiply. So let's think, well, if I make the 4 negative and I add them up, that would give us positive 1. So in this case, we want to make the 5 negative, so when I add the 2, it gives us negative 1. So negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. So my first factor is x minus 5, and my second factor is x plus 4. And those are our two factors. All right, let's try one more. So again, trinomial, our a value is 1. So our c goes on top for multiplication, b goes on the bottom for addition. So again, we need two numbers that multiply to make 18 and add to make negative 9. So if we do a little bit of thinking beforehand, if we're multiplying two numbers to make a positive and we're adding two numbers to make a negative, that implies that both values must actually be negative, right? Because a negative times a negative gives you a positive, a negative plus a negative gives you a negative. So now we just need to figure out what those two values are. So here, think of the different ways to make 18. Could be 9 and 2, but that doesn't add up to negative 9. Another way to make 18 is 6 and 3. So let's try negative 6 and negative 3. So if I multiply those two, it gives us positive 18. If I add them up, it gives us negative 9. So those are parts of our factors. Our first factor is x minus 6, and our second factor is x minus 3. So that's our quick review on how to factor a trinomial when the a value is equal to 1. Okay, so now we're going to keep factoring trinomials, but now you'll notice that we have trinomials where our a value is something bigger than 1. So here we have 2x squared and we have 6x squared. So when your a value is bigger than 1, we can't use that magic x method, so we have to use a different method. Now, there's lots of different methods out there for factoring trinomials like this, so I'm just going to show you one that involves a process called grouping, which I think will be a really useful skill for you down the road. So I really like using this method. So to start with this method, it's kind of like a number puzzle, just like in Magic X. We're going to be looking for two numbers whose product is actually the product of 2 and 15. So if we do 2 times 15, we get 30. So we want something whose product is 30 and whose sum is 11. So again, we multiply a and c, giving us 30, and then we use that b value here. So we're looking for two numbers that multiply to make 30 and add to make 11. So you can kind of go through the different steps of how to multiply to make 30. So maybe you say, okay, does 30 and 1 work? Well, no, 30 and 1 doesn't add up to 11. How about 15 and 2? 15 plus 2 is not 11. And then you can say, oh, how about 6 and 5? So 6 times 5 is 30, 6 plus 5 is 11. So these are our two numbers. So we're actually going to be using these two numbers, 6 and 5, and we're actually going to be rewriting 11x as 6x plus 5x, because 6x plus 5x is 11x. So we're essentially taking this middle term and we're splitting it up into two parts. Now, when you're writing the two parts, it's really important that you write them in the most beneficial order. So we still have 2x squared in the front, and then we have 15 for our c value in the back. And remember, we're going to be rewriting 11x as 6x plus 5x. I'll put a little plus sign in between. Okay, so if you're trying to figure out what order to write them in, compare the two terms on the side. So I see that 6x and 2x both are divisible by 2 and x, and I see that 5x and 15 are both divisible by 5. So I see that 5x is more related to 15 and 6x is more related to 2x squared. So I'm going to want to put the 6x here and the 5x here, and you'll see why in the next step. So just try to put them next to the term that they have more in common with. So now that we've split this up, again, these are completely equivalent. We're just writing it as two separate terms. We're going to use this process called grouping. So for grouping, we're actually going to group the first two terms together like this. And then we're going to group our second two, or our third and fourth terms together, and we're going to actually look for a GCF. What do they have in common? So in just these first two, again, they're both divisible by 2x. So here's that GCF method. We put 2x out front, and then we're just dividing. So 2 divided by 2 is 1, x squared divided by x is just x. And here, 6x divided by 2x is 3. And then in the second part, the GCF of 5x and 15 is 5. So I divide both by 5, put that GCF out front. 5x divided by 5 is x, and 15 divided by 5 is 3. Now, if this expression is factorable, you should end up with two things that are the same. So notice here that we have x plus 3 and x plus 3. So if you end up with two factors that are the same, that means that we can actually take these two terms, the 2x and the 5, and turn them into their own factor. So we can say 2x plus 5 and then times x plus 3. So that's the process of grouping, and then this actually is completely factored out. Now for ones like this especially, it's usually a good idea to quickly check our work. We can check our work using FOIL. So let's do that really quick. So 2x times x is 2x squared. 2x times 3 is 6x. 5 times x is 5x. And 5 times 3 is 15. And that gives us exactly what we started with. So we know that we factored it correctly. So again, we just need to start with that first step of finding two numbers who multiply to make that product of A and C, and who add to make that B value. So let's try part B together. So here again, we have a trinomial, but the A value is bigger than 1, so we can try that grouping method. So here, the product of 6 and negative 3 is negative 18. So we want two numbers that multiply to make negative 18 and add to make negative 7. So you can kind of go through the different ways of making 18. So maybe you're thinking, maybe it's like negative 6 and 3. You say, oh no, that doesn't add up to negative 7. Well, maybe it's negative 3 and 6. No, that doesn't add up to negative 7. Then you say, oh, maybe it's positive 9 and negative 2. Well, 9 plus negative 2 is positive 7, not negative 7. So we know that it must be negative 9 and positive 2. So remember, we're going to use these numbers to rewrite them like this. We're going to say negative 9x plus 2x, because that is equivalent to negative 7x. So we're just taking this term and we're splitting it up into two parts. Remember, the trick here is making sure you're placing your terms next to in the correct order. So let's see what we have. So we still have that 6x squared, and we have that negative 3. Right, those are the first term and the last term. So if I'm looking, I can say, well, 2x and negative 3, they have nothing in common. But negative 9x and negative 3 are both divisible by 3. 2x and 6x share a GCF, so I'm going to make sure to put 2x next to 6x squared and negative 9x next to negative 3. Again, we want to put it next to something that it has that it shares a common factor with. So now we can use grouping. So I'm going to group the first two, and then I'm going to group the second two. This time I'll just do it with highlighting like this. So we're going to group these two together, and we'll group these two together. So for our first two terms, I see that the GCF is 2x, so we can divide them each by 2x, and that gives us 2x times 3x plus 1. And here I can see that our GCF is actually -3. They're both divisible by -3. So let's do that. Be careful here. We are going to start by putting our GCF of -3 out front. A negative divided by a negative will give us a positive. So this actually gives us positive 3x. And same here, this gives us positive 1. And here we can tell that we're definitely on the right track because again, we end up with the same factor twice, 3x plus 1. So if you ever have that as the case, that means you can take their coefficients and group them into their own factor. So 2x minus 3 times 3x plus 1. So here we can quickly check 2x times 3x is 6x squared. Here this gives us 2x and this gives us minus 9x, which is -7x. And then multiplying the last terms gives us -3, so we know our factors are correct. Now factoring trinomials where a value is greater than 1. Again, it is probably a little more time consuming than the other ones. It requires a little bit more thought, but with enough practice, this will become kind of second nature and it will get easier. So make sure you get a lot of practice with this method if you're not comfortable with it. Okay, so now the last thing we're going to talk about are problems where you actually have to use maybe more than one method of factoring to fully factor your expression. So remember, anytime you are given an expression, there's always one thing you should check for first, and that's GCF. So for both of these, if you look at both of them, they both have GCF, so that's where we're going to start. So let's start with 8x squared minus 2. So both of those terms are divisible by 2. So that's our GCF. So we always start by putting the GCF right out front, and then we're just dividing. So 8 divided by 2 is 4. So we have 4x squared, and then minus 1. Now, sometimes after we use GCF, the remaining expression can be factored more. So hopefully you look at just this part inside the parentheses and you say to yourself, oh, I'm subtracting 2 terms, so you should think difference of 2 squares. Well, this is a perfect square, 1 is a perfect square, so this is actually factorable even more. So I'm going to write my A value. My A value will be 2x. My B value will be 1. Square root of 1 is 1, and I can factor that more. But don't forget, this 2 is still a factor. It was our first factor, so it's still part of our answer. So we have 2 times, and then we do A plus B, and then A minus B. So again, sometimes to get a fully factored expression, you have to use more than one method. So GCF, and then here we used difference of 2 squares. Now let's try the second one together. So here, if you look at these 3 terms, you'll notice that they're all divisible by 3, and since our x squared term is negative, let's also factor out the negative. So let's factor out -3 from every single term. So that's our GCF. Put it right out front and then just divide. This leaves us with positive x squared plus 7x plus 10. So then we look at our remaining trinomial and we say, hey, I wonder if I can factor this more. It's a trinomial. My A value is 1. Let's try using magic x. So we want 2 numbers that multiply to make 10 and add to make 7. And we know that we can find those 2 numbers simply 5 and 2. So this actually can be factored more, but remember the first thing we should write is -3. That's the very first factor, and it needs to be part of our final answer. And then our next factor would be x plus 5, and then x plus 2. So now it's fully factored. But again, this shows that we actually needed 2 steps or 2 methods to factor. First GCF, and then we used magic x. Okay, that is all for your factoring review video. Thank you so much for watching.